Hello, welcome to our demo video for cryogenic tank. Summer is coming. Today, when we talk about chip thermal management, what would you grab? Water cooling or air cooling radiators, we are all familiar, right? But how about something new, like compressor-using solution? In this video, you will see how the phase change cooling system we invent differs from the radiators mentioned above. Cryogenic tank vs some brand of 360 water cooling radiator sale in the market. This is a simple performance comparison test, covering CPU run score test and CPU toaster test. We use AMD Ryzen 9 5950X CPU, X570 motherboard, GT710 graphics acceleration card, etc. And Cinebench R20 CPU IDHW monitor, IDA64, Firmark for software. So let's begin. First of all, let me introduce the testing process. Set CPU frequency and voltage, then run score test, and then toaster test. This is a cycle, takes about 10 minutes. And we will test the 360 and our beta individually, over and over again, until downtimes. Okay, let's see the performance of 360 water cooling radiator first. Now, default frequency all-core 3.4 GHz. Cinebench 9803. Ten minutes later, according to IDA64, the final temperature reaches 83 degrees Celsius. Now, overclock to all core, for 0.25 GHz, 1.10 volt. Cinebench R20 score 10647. Ten minutes later, the final temperature reaches 83 degrees Celsius. We try to increase the frequency and voltage, but both the run score test and the toaster test fail, just downtimes, so this water cooling radiator reaches its full potential. Okay, then, it's time to test our cryogenic tank. skip the test of default frequency. And I will overclock to 4.25 GHz, 1.10 volt, let's see. Cinebench R20 score 10,595. Ten minutes later. The final temperature reaches 41 degrees Celsius. 42 degrees Celsius, lower than the equal condition and equal performance before. Go on, overclock to all-core 4.65 GHz, 1.33 volt. Cinebench R20 score 11,534. Ten minutes later. The final temperature reaches 83 degrees Celsius. We try to increase the frequency and voltage, but both the run score test and the toaster test fail, just downtimes. I will say that's because my piece of CPU reaches its full potential. Oh, I should have gone on the test of 4.65 GHz before. What would the lowest temperature be? But not just 83 degrees Celsius, who knows? Now, the tests come to a conclusion. Today we just test the performance of CPU. Vcryogenic tank is a global cooling system with an overload of a mainboard, a display card, and a memory. Despite of these, the figures of our tank are absolutely nice. Besides, the computing power of the CPU rise around 8% in vcryogenic tank, owing good deal to the big heat release and the fast speed of dissipation, of course. So there seems to be a considerable application area, and the computing power of semiconductor chips can be raised greatly by being combined with accurate temperature control technology. This may be beyond our wildest dreams. All in all, there are two main benefits of on-chip thermal management based on phase change system, especially compared with air cooling or water cooling solution. First, the system can produce greater and controllable heat flux by increasing latent heat, which can never be achieved on air cooling or water cooling solution. Second, the system cannot be affected by environment temperature. For example, if we are supposed to cool the chip to 10 degrees Celsius, when the environment temperature is 20 degrees Celsius, we cannot count on air cooling or water cooling solution, but just compression using system. If you want to know more information, welcome to call or email us. Thanks for watching.